Okay, so picking up with number 34 from your study guide, we're continuing the solving systems. So we have three ways we can solve a system of equations. If we have two different equations and we're looking for the point where those intersect, a visual of that, a good visual, is graphing. So the last example we did, we graphed the two lines and then we visually looked to see where they cross. So that's great, and I like that method, but sometimes it's not reasonable because you might cross in a fractional amount and not be able to pick that up just visually. Graphing calculators do that, of course, but we try to do this just purely without the graphing calculators and be able to see that. So we want to actually be able to graph it ourselves. But anyway, we're going to move to a different method, an algebraic method for solving the systems called substitution. So there's graphing, we did on the last one, then substitution we're going to do here, and then the last example, or actually not the last one, but 35 will say use the addition method. So we have three methods for solving. And sometimes one method works better with the problem than the other. So you can use any of these three methods depending on the problem, whichever one's your favorite. Okay, so substitution. The method says you solve one of your four variables out for that variable. Like solving for y, in this case, looks like our easiest route. You have this x, but they have coefficients. You'd have a little more trouble solving those, although it's doable. And then y, and then this negative 2y. So you want to pick the one that has just the 1 in front of it will be your easiest variable to solve for. So I'm solving for this y. So 5x plus y equals 17. To solve for the y, I just need to throw the 5x across the line, or minus 5x from each side. So now y is solved for. Y equals negative 5x and a positive 17. Okay, the reason it's called substitution is now you take that value, it says that y equals, and you sub that in for the y in the other equation. So we take the second equation, 8x minus 2y equals 20, and we change this y out. We sub it out for what it says y is equivalent to. So 8x minus 2 times negative 5x plus 17 equals 20. All right, then we're just doing an algebra problem again, one of those solving equations. The negative 2 is being distributed, so it's actually going to be positive because a negative 2 times a negative 5 we multiply will make a positive 10. So we get 10x, then negative 2 times 17 is negative 34 equals 20. Combine your variables, we have 18x minus 34 equals 20. We're trying to get x alone is always the goal when you're solving an equation, so there's only one x term in this, so let it set still, then take the minus 34 by plusing 34, it will disappear from the left side, plus 34 to the right. So 18x equals, that will be 54. Then the last step in solving equations is divided by what's with the variable, so divide by 18, and I think that comes out even to be 3. 54 divided by 18. So 3, now 3 isn't good enough. If you just type in 3 in Math Excel, it's going to count it wrong. You'll have to start all over. So 3 is just what x is. Remember, the solution is that spot, that coordinate where they cross. So we need x and y. So now that we know x is 3, we need to know what y is. And this is probably the easiest place to find y. Y is negative 5 times the x value plus 17. Find it here. You can actually find it here or here by plugging in x is 3 into any of the former equations. You can find y. This is just the easiest spot. So y will be negative 5 times the x value of 3 plus 17. That's negative 15 plus 17, which is 2. So y is 2. So the answer is the coordinate x is 3, y is 2. That should be the point where those two lines cross. That also should be the value that makes both of these equations true when plugged in for x and y. All right, moving on, number 35 asks us to solve by the addition method. The addition method is where you're actually going to add your two equations together such that one of the variables will drop out. Now, this one's set up so that it will just naturally do that. The next problem we see won't just naturally add out one of the variables, so we'll have to do some groundwork. But notice here, x and negative x, if you add those together, drops out the x's. That's what you want to happen, is one of the variables to cancel out. So the addition method adds the two equations together, so you need to line up your x, y's, and numbers to start it. X plus negative x nothing. 6y and 7y is 13y. 39 and 39 is 78. And then this is solvable. Since there's only one variable, we can divide by 13. And y equals, I think that is 6. So the y value is 6. As always, like I said on the last problem, you need to know the x and the y. So just knowing y is 6, don't stop there. You need to find its x value. I don't have a nice easy place to find that on the download substitution method, but I can go up to one of the former original equations and plug in y is 6. Okay, so let's take this first one. X plus 6y is equal to 39. And sub in the y is 6. And that will allow me to figure out my x value. So x and 36 equals 39. Minus 36 from each side gives me x is 39 minus 36, or 3. So the solution is that coordinate x. Make sure you put the x first, comma, the y value. 3, comma, 6 is the solution. Okay, next example, the last one from chapter 7, also asked me to use the addition method, so I want to add these two equations together, just like before, but something needs to drop out if this is going to work, if it's going to be solvable. If I add it as it is now, negative 2x and 3x will be 1x. I'll still have an x, and 6 and minus 3y, I would still have a y. I would still have two variables, so that wouldn't help me. So I need to do some groundwork so that when I add them, either x or y will be 0. So what I can do is try to make my x's the same or the y's the same. It's really up to you. But I could make this a 6y pretty easily. If I doubled all these numbers, that would be a 6y, a negative 6y, and a positive 6y would drop out. Now I'm not allowed just to go around changing numbers around, but I am allowed to do the same thing through an equation. As long as you do it to left and right, you keep the balance. So if I were to times this equation completely through by 2, that would change it to 6x minus 6y equals 2. Just doubling each term, and it's basically the same equation. It just has bigger numbers, but it's same value, same basic equation. Now this equation and the first equation, negative 2x and 6y equals 18, can be added together, and the y's will cancel out. So negative 2x and 6x is 4x. 18 and 2 is 20, and now it is solvable by dividing by 4. I can know that x is 5. Again, don't stop there. That's just the x. That's the hard part. But I do need to know its y value. So go up to any of the former equations. Remember, there's no magic here. It's whichever one that you want to use, and plug in x is 5 to figure out y. I'm going to take the first equation, negative 2x and 6y is 18. Plug in x is 5 will be negative 2 times 5 plus 6y is 18. That's negative 10 plus 6y is 18. Solving for y, so I need plus 10 to cancel that out. 6y is 28. Divide by 6. 28 divided by 6 doesn't come out perfectly, but it does reduce to 14/3. So the solution should be 5, 14/3 for that solution. I should look at the answer key and make sure it doesn't ask us to leave that as a decimal. Let's see, that's 36. Yeah, it left it as 14/3. It's always good to double check and make sure the directions. Sometimes they'll ask to leave a decimal and round, and sometimes a fraction is probably understood unless a decimal has to be rounded. Okay, so that would finish up chapter 7.